Okay, previously we had looked at differential equations through a slope field, which is a graphical representation, and then also Euler's method, which is a numerical. Now we're going to go ahead and practice solving these differential equations by separating variables. Okay, we've actually done this before, but we did very simplistic problems. Okay, here is a differential equation, just an equation with the derivative. I would always recommend rewriting that y prime as dy dx. Okay, before you can integrate, you can only integrate if the y's and the dy's are together and the x's and the dx's are together, and it has to be multiplied by dy and it has to be multiplied by dx. So the dx, I'm going to move over here, it's going to get multiplied on this side. You're going to have to divide the 1 plus y here, because if you just subtract the y, it's going to be negative y plus dy. It always has to be multiplied by dy. So I need to actually divide that whole entire piece over. So this is our first step to separate our variables. The y's are with the dy. It's 1 plus y to the negative 1 really times dy, and then dx. Take the antiderivative both sides. You have natural log of 1 plus y. This is x plus c. You only need to put the plus c on one side. There really is a plus c here and a plus c here, but you can move all the numbers to one side and just make it one constant. Okay, we're going to rewrite the log as an exponential because you do have to solve for y. So this is e to the x plus c is equal to 1 plus y. Okay, solve for y. I have y equals e to the x plus c minus 1. Okay, I'm going to show you one other simplifying technique that's going to help us when we have to simplify our answers. Okay, this, using properties of exponents, is really the same as e to the x times e to the c, right? We add our exponents, but e raised to a number is still another number. So I'm going to call this c. Now obviously this c is not the same as this c, but it's fine if you use the same letter. So this whole piece, I'm going to rewrite it like this. So this is my general solution. Now I do give you a point to use, so I'm telling you that y of 0 is 1, so when I plug in 0 for x, I should get out to 1 for y, and if you solve this, c ends up being 2, so 2 e to the x minus 1 equals y. Okay, you always want to do this simplifying step, because if you have to use this equation for something else, it'll become much easier to work off of this than this equation. Okay, let's look at another one on the next page, page 10. So again, I always start by rewriting. If you see y prime, f prime, just write it as dy dx. Okay, step 1, always separate your variables. Again, I do have to divide by the y minus 2. I'm going to move the x over here. Antiderivative both sides. This is, again, natural log of y minus 2 equals x plus c. Rewrite it as an exponential. Base is e. This whole piece is your exponent. Make sure the plus c is up there as your exponent. Like we did on the previous problem, this is really the same as e to the x times e to the c, but e to the c is still a number, so I'm just going to call it c. So I'm going to rewrite this piece as c e to the x, add the 2 over. There's my general solution. The point that you're given is 0, 4, so if I plug in 0 for x, I should get 4 for y, so then I can tell that c has got to be 2. So this is my particular solution. Okay, let's try one last one, page 11. Okay, same thing. Start with dy dx equals 2y plus 1. Again, you cannot subtract the 2y because then it becomes negative 2y plus dy. It always has to be multiplied. So I'm going to go ahead and divide by this again. Oops. And then you're going to integrate both sides. Okay, be careful on this one. Notice that all the other ones, your u was like y minus 2, y plus 1, so your du and your dy were the same. But here, since your u is 2y plus 1, your du is actually 2 dy. right? So you always need to be thinking u du. So this is going to be natural log of 2y plus 1, but you're missing a 2, so I need a 1/2 in the front. This is x plus c. Okay, going back to pre-calc, before you can solve this, you have to get the log by itself. So that 1/2 needs to get multiplied out. So this becomes 2x. Now, 2 times a number is still a number. If you write it as plus 2c, it's fine, but then you have to carry it all the way through. 2 times a constant is still another constant, so I'm just going to leave it as a c again. Rewrite it as an exponential. E to the 2x plus c equals 2y plus 1. Simplify. C e to the 2x minus 1 all over 2 is equal to y. This is my general solution. I give you the point y of 1 is equal to 5. So if I plug in 1 for x, I should get 5 for y. If you solve this, you should get c equal to 11 over e squared. So plug that back in, so you can write it as this, 11e squared times e to the 2x minus 1 all over 2 equals y. Or, using the properties of exponents, this can also be rewritten like this. Right? When you divide, you subtract your exponents. So this is another form of the equation.